Hey, good evening, guys. So this is going to be the last extra tutorial on partial derivatives, okay? So for this topic, we're going to actually focus on total, wait, let me just make that yellow. Sorry about that, yeah. On total differential, okay? On total differential, and of course we have small errors, right? So total differential and small errors. All right. So if you guys remember the formula that we discussed during the tutorial session, that this formula, right, it's simply del U, all right, where U is basically estimated the change of the total differential, okay, it's estimated as del F, right, del X dx plus del F dy, okay, dy. Oh, sorry, actually, the formula actually includes, sorry, the formula is actually, this one's, right, my apologies for that. It's supposed to be delta x and delta y. And if you have the z term, also we can include del f, del z, alright, delta z, alright? If we have three variables, okay? So normally when we use such formula, this formula we use whenever, let's say, we have error in regarding to x. So for example, we have errors, right? We have errors in x, y, and z, for instance. Okay. So if we have errors in that, we want to know, we want to find what's the errors in u. So we want to find the error in u. In u. Okay, u actually is basically the output of the function itself, right? U is basically like the output of the function itself. Once we do a couple of problems, we will understand what's going on. And x, y, z, I like to remind again, are the input, right? So yeah, let's do a couple of problems and then we will actually understand this better. Okay, let me just erase this. Make this a bit bigger, unfortunately. Okay, so with that being said, okay, so let's go to the textbook. Let's see your problem. Okay, right, let's look at a problem right here. Let's see. Okay, so we know that the book has given us a problem here, so I'm going to write it down. So we know that the area of a triangle, okay, triangle ABC is calculated with the formula. Okay, I'm gonna write the formula right here, where A is the area. That's not A. Okay, it's S. Okay, S is referring to the area. Half BC sine A. So if I were to draw the triangle, actually let me choose orange. So you have a triangle right here, okay? And this is your angle, okay? This is your angle, which is A. And we have the sides B and C, okay? So they are saying that the area of the triangle is expressed in this particular formula, S equals to half BC sine A. And now it is mentioned that the percentage error, so the percentage error for B, C, and A is 1%. All right, they already mentioned that. So they're saying that if A, the angle A, is measured at 45 degrees, show that the percentage variant, the percentage in S is not more than 2.8%. Is not more than 2.8%. Okay, so this is the question from the textbook, right? Where we're given the area of a triangle here. S actually refers to the area, by the way. Okay. B and C are sides of the triangle, I think, which I've labeled them right here. And A is the angle, okay, between B and C, supposedly. And they said that the percentage error for B, C, and A is 1%. Now, if A was measured at 45 degrees, we have to show that the percentage error, okay, in S is no more than 2.8%. So how do we do that? So I recommend you guys to pause the video first and try to screenshot the question or try to copy the question down in a notebook if possible, right? Before I erase it and try to start solving it. Okay? Okay. So I assume that you guys have already taken your time to screenshot the question or copy it down in your book. So I'm going to erase this right now so I can start working on the answer. Okay. So if we remember that the total differential formula, right? The total differential formula we discussed earlier. So the total differential, okay? The total differential formula, okay? So we have here delta S equals to del S del A, all right? Delta A plus del S del B delta B, yeah, plus del S del C delta C. Okay, so that's the total differential formula. And one thing to remember is that when we are, trying to solve for this, right? When you're trying to find the delta S, okay, of course we need to differentiate the function with respect to A, B, and C using partial derivatives. And of course, the delta A, the delta B, and the delta C are already given to us. But in terms of percentage error, they're not given to us exactly. So we know that the percentage error is obviously, sorry, the percentage error is obviously 1%. And this one also is the same for delta B and delta C. But percentage error, yeah, this is not the actual error. This is a percentage error. Here they want the actual. This is what we talk. They want the actual error, which we don't have, by the way. So how are we going to find the actual error? Well, the truth is we don't. Instead, we can actually use the percentage error to figure out the answer, right? To find the percentage error of delta S. So just recall, okay, let me just take a pen right here. Actually, now I'll also erase this first. Let's erase this first, by the way. Okay, okay, right. So, okay. So just to recall that for percentage error, whenever we're discussing a percentage error for any variable, right? What we've learned in college or A level mathematics or even high school mathematics as well and physics or chemistry, whichever subject you learned it from, percentage error is always the change, right? Okay, why did I put a along here? Okay, so obviously the change, right? The change in change in reading, meaning change in reading from what? Maybe from new and original, huh? So from new minus original. Okay, I'll just write original ORI, okay, over the ORI times 100%. That is the percentage error, what we all know actually. And sometimes it can be new minus original or original minus new. Okay, it doesn't really matter which one comes first with the order, because end of the day, this change will be in modulus. Okay, so modulus, sorry, that was really bad. So modulus means that the change will always be in positive. Okay, so it will always be in positive value. Okay, so there's nothing to worry about. All right, so let me just erase this real quick. So this is a recap on percentage error. So in our case, when we're talking about percentage error, so percentage error, let's say for example, we talk about percentage error of A. So the percentage error of A is just simply delta A, right? The actual error in A, okay, times the original value of A that we got, multiply by 100%. And we know that value. That value is actually 1%. We know that value, right? And likewise, if I were to also repeat it, maybe for example, okay, let me write down right here if you can see it. Percentage, okay, error of B is the same. It's just delta B over B times 100%, which also we know is 1%, right? It's already given to us. The same thing also for C as well. We already know that the percentage error for C is 1%, right? So the question actually wanted us to find the percentage error for S. They wanted to find us the delta S over S, right? So how are we going to find that? Well, first and foremost, what are you going to do is we're going to find a percentage error for all of this. All right, we're going to find delta A over A, delta B over B, delta C over C, as well as the partial derivatives. Okay, so let's just proceed with this first. Okay, so the thing is, we know that delta A over A is just equivalent to 1% divided by 100%. In other words, it just becomes 0.01. And then similarly, delta B over B is just 0.01. Delta C over C is also 0.01 because they all have the same percentage errors. When we divide by 100, in the end of the day, you should end up having the decimal 0.01, 0.01, and 0.01. Okay. Now, the partial derivatives. Okay. So first, let's start with del S, del A. So del S, del A is very simple because our only concern is obviously be the sine function. We're only interested in the sine function. Everything else is a constant. So therefore, it's just half BC cos A. Okay. And then for del S del B, it is just, since we're only concerned with the B, I'm going to highlight this in white, by the way. Right, we're really just interested in the B, so it will just be half C sine A, and of course del S del C would be half B sine A. Okay, so with that being said, let me of course clear some space because we need some space to write them down. So I'm gonna erase this, right? I'm gonna erase this and the triangle. Okay, so in this case, right? Um, obviously we already know that we already got the del S del A, del S del B, del S del C, and we got delta over A, delta B over B, delta C over C. Now, if we write the formula like this, so delta S over S equals to del S over del A, right? Times delta A over A plus del S del B delta B over B plus del S del C delta C over C. Okay, so all right. So with it being said, so delta S over S equals to half BC cos A times what? Times with 0.01 plus del S over del B is half C sine A times, sorry, C sine A times 0.01 plus half B sine A times 0.01. Wait, I think I'm missing something actually right here. Wait, actually, I think I'm just missing a little bit something here. I just realized that I forgot something. Otherwise, it would make this whole thing a little bit more tricky. Mm, okay, okay. I see what's my mistake here. Sorry, actually, yeah, I just forgot to introduce actually something here. My apologies. Right, right. It just didn't click to my head initially. So, actually, right, when we introduced the term, right, we introduced the divide with s, right? We introduced divide delta s over s. That means that for even these functions, we also have to divide with s as well, right? We have to divide with s as well. Okay, hopefully that makes a bit more sense now. right? Because you want, if you divide on the left hand side with the letter S, don't forget to also divide on the right hand side as well with the letter S. And just for reference, if you guys already forgotten what the letter S was, S actually is the area of the triangle, which is half BC sine A, right? So don't forget that. Okay. So with that being said, let's continue to solve the problem. So let me just erase this, by the way, just so that it doesn't create. Okay. Okay. So delta S over S equals to half BC cos A times delta A over half BC sine A. Okay. Plus half C sine A delta B over half BC sine A plus half B sine A delta C over half BC sine A. Okay, with that being said, we erase all this real quick and let's do some term cutting. Let's cut out some common terms. I'm going to use green, by the way, for this. So you can see that sine A is common, C is common, half is common. Okay, it's all one, right? Same thing also. Okay, so it's just one, and this one is just half BC is common. So we end up with delta S over S. Okay, we get cos A over sine A times delta A plus delta B over B plus delta C over C. Okay, so uh one thing, if the question is mentioned to us, is to remember that our angle A, right? They said that if angle A is 45 degrees, okay, we need, it will mean that the delta S over S, the percentage error, should be 2.8%. Okay, it should not be more than that, to be honest. Okay, actually, it's not equal to, it's more, it's actually what? It should be less than or equal to 2.8%. Hopefully, this is clear, right? And okay, so I'm gonna have to erase this, by the way, this is quite distracting. Okay, okay, all right. So as we proceed with delta S over S, we know that cos A over sine A, we could just simply put cos 45, okay, over sine 45. Okay, so delta A, if you remember correctly, that delta A over A is 0.01. So delta A is just 0.01 times A. So 0.01 times A is, well, 45 degrees. So interesting, we put 45 degrees right here. Okay. Plus delta B over B, we remember 0.01 plus delta C over C is 0.01. Okay. So if we compute this with the calculator, cos 45 over sine 45 times 0.0145 plus 0.01 plus 0.01. Oh, okay, that's not right here. Wait, let me check what's the issue here. Hold up. 45 times. Okay. So, yeah. Okay. So, here's actually a thing I want to explain, by the way. I know this is a bit of a cheeky trick, but let me explain here. This 45 degrees, you cannot compute directly with 0.01. Okay? Because 45 degrees is an angle, so if you want to express it to a way to compute, you have to turn this from degrees to radian. Okay? Normally, when you're dealing with simple computation like this, normally it's advisable to convert angles from degrees to radian. Okay? This one also is 45. You can also convert to radian. I believe if it's in radian, it should be about 45 over 1. It should be about 1 over 4 pi. Okay? It should be about 1 over 4 pi. So cos 1 over 4 pi, sine 1 over 4 pi. Okay? And this one obviously is going to be 1 over 4 pi. Okay, and 0.01 0.01 is completely 0.01 0.01 is completely fine. And if you compute it, I believe that we get about what's 45. Let's see. One second. That's right. We get about um 0.0279 0.0279, which if we were to convert it properly, it's about 2.79%. And 2.79% is exactly what we're looking for because we wanted to make sure that del S over S is clearly not more than 2.8%. And we've already managed to prove here with this answer. All right. So yeah, that's actually how do we solve this question, by the way. Okay, just the last step. I know it took me off by surprise also, but I realized that yes, we have to really use radians and not degrees because we're actually computing 0.01, okay, with 45 degrees. And normally a normal number like 0.01, we don't really just multiply 45 degrees and get the answer. It'll be pretty much wrong. That's why we have to convert it to radians, okay, because radian usually is like the normal way we would compute angles, especially let's say, let me give you another example, right, with radian. Why, when do you use radians? Let's say we have a case on, how do I say this? Let's say on distance, for instance, right? Let's say, for example, you have an object, okay, which, moved at, let's say, about 50 degrees, okay, moved about 50 degrees, all right? And they mentioned that the distance usually for this object has moved. It's basically cos 50 degrees, 50 times t. Okay, let's say the displacement of the object. Okay, 50 degrees times t. That's right, 50 times t. My apologies. Cos how do I say this? Cos, let's say 2 t, for instance. Okay, but you only know 50 degrees. Okay, therefore, it is advisable that you have to convert it to radian, by the way. Okay, so you have to convert this to radian. So 50 over 180 times pi. Okay, therefore, you would be able to, you know, compute things like displacement and velocity. Although the example I might have given you was a little bit of a shabby example, but normally when we're dealing with angles in degrees and we're computing with normal numbers, okay, they've highlighted here, it is wise to use radians actually, not degrees. So we have to avoid using degrees, convert to radian right away. Okay. One example, like I said, maybe for example in displacement equations, but as I said before, this might not be a very good example. There might be better examples out there, but that's the main gist. That's the main idea behind it. Okay. So we're done with this question. All right. We've already managed to prove. We're going to the next question, by the way. Let me erase this real quick. Okay. So let me erase that fast. All right. Okay. I think the screen is clear. Okay. Let's go to another problem. Okay. Let's see which problem is selected here. Okay. Okay. So there's a question here about a coal processing plant. Okay, let me write that down by the way. So it's about a coal processing plant. Coal processing plant, right? And the flow, the flow equation, by the way, the flow V of slurry in a pipe, okay, is given by, okay, and the equation here actually is V equals to pi times P r to the power of 4 over 8 u L. Okay, so this is the equation given to us. All right. So they've already mentioned the percentage changes for all these quantities, right? So they mentioned that the percentage change from for R, delta R is 5%. So delta R over R times 100%, they've already mentioned that it's clearly 5%, okay? 5% increase. All right, delta L over L, okay? We'll multiply this by the way, 100%. Also is a 5% increase, okay? And delta P over P times 100%, okay? It's a decrease by 10%, so we're gonna put negative because it signifies a decrease. And delta nu over nu, it's not n by the way, yeah? It's nu times 100%, okay? It turns out to be a decrement in negative 30%. Let me just make sure I got that right. Okay, so they want to find out what is delta V over V times 100%. the percentage change of V. Okay, so they want to find out what is the percentage change of V. So take your time. You guys copy the question, and I will assume you guys pause this video to just to copy the question or screenshot it, and later we can discuss the solution together. Okay? So I assume you guys have given it a shot, and now we're gonna try to solve the question together. Okay, let's erase all that. So obviously to find the percentage change in V, right? Right, so you want to find delta V, okay? It's just simply delta V over V. Of course, we have to find all the del V. So del F, del V, my apologies, my del F. Del V over del P, delta P, plus del V over del R, delta R, plus del V over delta nu over del nu, delta nu, okay, plus del V over del L, delta L, right? Of course, all of this will be over V, right? And then obviously you can easily solve and get the answers. So first of all, we need to find what is all the partial derivatives, right? So let me just write down here. So delta V over del P, okay? Again, everything is a constant, so nothing to worry about. It's just simply pi r to the power of 4 over 8 and nu L, okay? Then we have del V over del R, all right? Same stuff, it's just 4 pi p r cubed over 8 and L, okay? Now we come to the other derivatives. Let me actually just erase this by the way because it's taking a bit of space. Okay. Then we have del V over del N, alright? So everything is just a constant, is just pi p r to the power of 4 8L times negative nu to the power of 2, which we can simplify this as just simply, actually can rewrite it to be honest. I can just rewrite it right away. This becomes a negative, right? It's a simple negative right here. Negative nu squared. Okay, there you go. And del V over del L, same thing. Negative pi p r to the power of 4 over 8. Oops. And sorry, L squared. Yeah, I'm getting a bit sleepy. That's why I end up pronouncing new as L, L as new. So I hope you guys don't mind. This is just, me being a bit tired. I do apologize for that. Okay. And yeah, so we already know that. Now it's our job to rearrange the equation. Okay, so let me erase this first. I need a lot of space. Yeah, I need a lot of space. Okay. Okay. So clearly we need the delta V over V. Well, let me just write nicely. Delta V over V equals to what we have just written earlier, right? is just simply pi r4 over 8 nu L, right? Times delta P plus 4 pi P r cube over 8 nu L delta R minus pi P r to the power of 4 over 8 L nu squared minus pi P r to the power of 4 8 nu L squared. Okay. I actually forgot something important here. Just let me. I completely forgot about. Wait. Almost forgot about the delta nu minus pi P r to the power of 4 8 nu L square delta L. Okay. Um. Okay. Over what? So delta over V. So our V function, if you guys remember, is just pi P r to the power of 4 over 8 nu L through L. Okay, this is our original V equation, huh? This is our original V equation. Okay, so with that being said, let's just simplify the. Okay, hold on. Let me just drag this down a little bit. Oops, sorry. Let me just drag this down a little bit. Okay, there. So yeah, that was an accidental drag, by the way. My apologies. So with that being said, we can easily find delta V over V, right? So with delta P, you can cancel almost every factor, right? It's just all the factors are common. You just only have uh P over delta P, right? So you just only have delta P over P, okay, plus for again R cube, you could cancel out almost every factors. By the way, it's all common factors, 8 and L, P, except for the 4. And then this is just simply 4 delta R over R. Okay? Minus, now for delta nu, well, you can cancel out the top, but for the bottom, you still have, interestingly, you still have 1 over nu squared. Okay? 1 over nu squared over 1 over nu. Right? Yeah, 1 over nu. Because everything else is still cancelled out, right? And you have delta nu. And the last one, also the same thing, just 1 over L squared over 1 over delta L. Okay, so I'm gonna go and simplify it. So just delta P over P plus 4 delta R over R minus, well, if you tend to flip it out, it just simply becomes nu over nu squared delta nu minus delta L. And then becomes new 1. So yeah, so it becomes delta P over P plus 4 delta R over R minus 1 over, sorry, it just becomes uh, delta nu over nu minus delta L over L. Okay, so if you recall correctly, delta P over P, as we've discussed earlier, is 5%. Or delta P over P is negative 10 over 100. Okay, so it becomes negative 0.1. Delta R over R, it's positive, right? It's increasing by 5%, so it's just 5 over 100, so 0.05. Delta L over L is also 5 over 100, so it is just 0.05. And delta nu over nu, oops, nu, okay, is negative, is decreasing by negative 30, so it's just negative 30 over 100, so it's negative 0.30. Okay, so with all that in consideration, so just negative 0.1 plus 4 times 0.05 minus negative 0.3 minus 0.05. So the final answer, if you want to compute everything together on the calculator, okay, sorry, minus negative 0.03, sorry, 0.3, minus 0.05, yes, 0.35. So 0.35, okay, 0.35, which we can obviously say it's 35%, okay? So therefore, we can conclude that the percentage change in V, okay, it increases, okay? It increases by 35%, okay? So yeah, that's about it actually for all the tutorials on partial derivatives from the book. And I hope that this is really helpful to you guys. And I'd like to add an apology that, yeah, sometimes the videos might take long. It might seem a little bit unscripted and all that, but that's because that is me actually doing it in real time right now as I am, solving the problem at the same time as looking into it. So, yeah, that's why it seems a little bit messy, because I actually wanted to give you guys like a raw idea, like a raw understanding of how I solve these problems as well, right? How do I approach this problem? So at least, there's a common ground between you and me, like as a student watching this video and as a tutor, we face a common ground, we face the common challenges together, solving calculus together, right? So hopefully I will make more videos, obviously, on other topics, and hopefully this will be very beneficial to you guys. And once again, thank you.